Here's our first lesson on Unit 6 Earth's History, and this is all about the rock cycle. So here's just a quick overview showing that the rock cycle is just the processes that rocks on Earth's surface and beneath the surface follow to change between the different types of rocks. There are three main types of rocks you can see here. There are igneous rocks, sedimentary rocks, and metamorphic rocks. So just a little bit of information about the three main rock types. The first we'll talk about is igneous rocks. Igneous rocks form from cooled magma. These are considered to be the only new kind of rock because sedimentary and metamorphic rock both form from already existing rocks, whereas igneous rock forms from cooled magma, so it's the only new kind of rock. There's two categories of igneous rocks that we're going to be concerned with, intrusive and extrusive igneous rocks. So intrusive igneous rocks, remember intrusive volcanism means that magma never erupted and then just cooled underground and formed some kind of feature. So that's what an intrusive igneous rock is. It cooled underground very slowly. Extrusive igneous rocks form above ground from erupted lava, and they cool much more quickly because it's colder outside the Earth than it is inside the Earth. There's also this category down here called plutonic igneous rocks, but we're not as concerned about those for this class. We're going to be talking about intrusive and extrusive. So up here in this picture, this is just to show you that there's a lot of different colors and textures that igneous rocks can come in. Second category of rock is the sedimentary rocks. Sedimentary rocks form when weathering breaks already existing rocks into small chunks called sediment, so tiny little grains of sediment. Erosion then carries the sediment away from wherever that rock broke down, and then the sediment is deposited in the act of deposition. So you can see in this diagram here, there's this material, this sediment that has been broken down from other bigger rocks, carried by the wind and by just rolling down the hill into the sea, and then it forms layers on the seafloor, and over time they get compacted into rock layers in the deeper areas of the seafloor. So lithification is a word we use that means turning into rock. So this is when the sediment that's been broken down from existing rocks gets compacted and cemented together by physical force, and also by a little bit of some chemical processes can cause natural cementation of these sediment grains to turn into sedimentary rock. Sedimentary rock is the most likely one to contain fossils. So if you ever are outside looking around, like if you walk up to the top of Mount Helena and you find some rocks with fossils in them, lots of little seashell fossils exist up there, it's because you're looking at some sedimentary limestone type rock. So this picture again is just to show you there's lots of different colors and textures that a sedimentary rock can exist as. Our third and final category of rock is metamorphic rock. Metamorphic rock is formed when extreme heat and pressure partially melts already existing rocks, and then as those partially melted rocks cool, the minerals recrystallize in a different pattern than they were in before the rock was partially melted, and that is what forms a metamorphic rock. So it's like one rock has heat and pressure on it, and then it changes into another rock, like metamorphosis, like a caterpillar changing into a butterfly. This is one rock changing into another rock due to heat and pressure. Typically when this happens, rocks become harder than they were, so metamorphic rocks are really quite hard. Here's an example here. You've got heat from this magma, pressure from these layers above, exerting down on this rock here, and so this rock is going to form, it's going to undergo metamorphosis and form metamorphic rocks. So again, a picture just showing a few different examples of colors and textures of metamorphic rocks. So just to kind of review the different processes that can cause one rock to move through the entire rock cycle, you've got magma that cools and solidifies into igneous rock, so then igneous rock can undergo weathering and erosion and turn into sediment that turns into sedimentary rock. Metamorphic rock can also undergo weathering and erosion and turn into sediment and be turned into sedimentary rock. Sedimentary rocks can undergo heat and pressure, turn into metamorphic rock. Igneous rocks can undergo heat and pressure, turn into metamorphic rocks. You can even have metamorphic rocks that underwent a little bit of metamorphosis be subjected to even more heat and pressure and turn into a higher grade of metamorphic rock. You'll notice here that there's no actual step between sedimentary rock and magma. You can have igneous rock that melts into magma and recools into different igneous rock. You can have metamorphic rock that melts into magma and cools into an igneous rock. But sedimentary rock doesn't typically melt into magma because if it's getting hot enough for sedimentary rock to be even close to approaching melting, it's probably going to turn into metamorphic rock first before it ever gets hot enough to actually melt. So again, just overview of the rock cycle. One rock can move through all of these different stages over millions or billions of years.